So we're going to find out how fast you have to run straight into a train to stop it in its tracks, using momentum, of course. So the equation for this, to figure it all out, is it's not too bad actually. It's just momentum before is equal to momentum afterwards. Now, I'm not going to lie, this is a big, ugly looking equation until you realize it's not actually that big. It's just two little things copy pasted 4 times in a row. So let's have a look at it. The momentum of the man there, that's his mass times velocity, because momentum is mv. The train momentum is just his mass times velocity, and then they'll give you the numbers afterwards. So after these guys presumably crash into each other. That guy there has got minus 40. That just means he's going the opposite direction, so it's a minus. And then when they collide, let me just get rid of this for a second, you're going to find that they actually kind of stick together. And their velocities will be 0. So the man stops, the train stops, and they kind of just fall down on top of each other. Okay, I'm not saying this is what's actually going to happen if you run straight into a train, but certainly this is what the maths, simplistic version of the maths predicts. It's kind of true a bit. So if you get this equation, and it looks ugly, but you'll see it gets nicer as we go through it, and then gets uglier, and then gets nicer. So momentum is just written as mv. We saw that before, so that's p equals mv. So we can just say mv for the man here plus mv for the train is equal to the same just afterwards. Okay, so that's why I said it's just the same thing copy pasted 4 times in a row. And really the guts of this question is just filling in all those m's and v's, and they tell you what they are. They tell you what they are up here, so it's not too bad. Okay, let's do it. Let's fill these in. You got your m and your v for the man. So m is 75 and v I don't know. It's m is 75. V I will just leave it as b because I have no idea what it is yet. You're not supposed to. M is 40,000 for the train. V is minus 40. So 40,000 minus 40. I'm just subbing these in here. Okay. MV for the train afterwards. Not that's for the man even. MV for the man afterwards. I've got 75 from my mass. It hasn't changed. No bits have come off. And 0, which means I'm stopped. And that's because I was told that in the question. Okay, and it's the same mass again, and the train is stopped, so that's 0. So these two come from up here. Okay, now it gets a bit nicer now, because these lads cancel out, because anything times 0 is 0, so that's 0. This is also 0. Happy days. We're going to be left with a 0 here for sure. And we are. Now, because we need to solve for v, we're going to have to do some algebra here. So what I'm going to do is I'm going to bring the 1.6 million, it's going to be a nutty answer, over here. That's going to become a plus, and then I'll probably just divide by both sides by 75. Okay, and what you're going to be left with is something like this. I'll just look at this bit for the moment. So you're left with this big kind of fraction, and you just simplify that. You divide 75 into the big 1.6 million, and you're left with 2,133 meters per second. What that means is that's actually the speed you're going to have to run into that train to stop it. So 21 kilometers per second is so fast that you would go pretty much from the ground into outer space in just over a second. You'd be going so fast towards this train that you'd be more like a kind of like a fireball, because you'd be, the amount of friction of the air at that speed, you'd probably just burn up before you'd even get to the train, to be honest. But it would look cool as anything, and then it would stop the train. I don't think you'd survive. In fact, even if there was no train there, literally traveling at that speed in air would burn you to a crisp. But it's cool to think about.